Hello, today I am here to talk to you about linear probabilistic modeling. First, what is linear probabilistic modeling? Well, its official definition is that the linear probabilistic modeling is a special case of a binomial regression model where each observation is given a value of 0 or 1. The probability of observing a 0 or 1 is then dependent on one or more explanatory variables. On screen is an equation for finding the model, where beta 0 is the base probability, beta 1 x1 is the dependent variable for x1, beta 2 x2 is the dependent variable for x2, and so on. Now, this may seem confusing at first, but I like to think of linear probabilistic modeling in the way of coding. And if you know something about coding, it deals with successes, ones, failures, 0. We can plot these on a graph and then give us a rough estimate of what the population will do. But that being said, it is not as precise as the equation from the previous slide. So I just like to use it as simplifying the subject of linear probabilistic modeling and not using it for an exact case. Furthermore, here we move on to a real-world example. In the real world, engineers are constantly vigilant for parts that are deemed defective. Linear probabilistic modeling can help with that. If we can see here from the graph, a model such as this is good for determining how a population will act in the future based on the tests of the now population, calculating how many parts may or may not be defective. While this is just a simple case, and in the real world, engineers would have to account for a variety of things, it is a good model for displaying what could happen to a population, where we are looking for successes and failures of such, and using how the population reacted before, we can see what the population will do in the future, and look to minimize the amount of defective parts that slip through because we already know how many parts we should expect to be defective from the population given before based on the modeling. Thank you, and I hope I explained everything well and clear.